Hello everyone. Welcome to today's video. Today we're gonna see about an interesting problem which was frequently asked in Microsoft. The task is to calculate the total number of downloads for both paying and non-paying users grouped by date. Only include records where non-paying customers have more downloads than paying customers. The output should display three columns: date, total downloads for non-paying users, and total downloads for paying users. The results should be sorted in ascending order based on the date column. In essence, we are analyzing download data to identify dates where non-paying users had a higher total number of downloads compared to paying users. The output will show the date along with the respective total downloads for both non-paying and paying users, sorted chronologically from the earliest date. Let's get into the challenge. Before that, please preview sample table and expected output once before solving. Alright, let's break down this SQL query step by step as we are solving this challenge. Step 1. Understanding the data sources. The query involves three tables: ms_user_dimension, ms_s_dimension, and ms_download_facts. These tables likely contain information about users, their account details, and download data. In this part of the SQL query, two sum functions are used with case when statements to calculate the total downloads for paying and non-paying customers separately. Here's how it works. Calculating paying downloads. The expression sum, case when paying_customer equals yes, then downloads else 0 end, calculates the total downloads for paying customers. For each row, it checks if the paying_customer column is yes. If it is, it includes the value in the downloads column for summation. Otherwise, it adds 0. This effectively sums up all the downloads for rows where the customer is identified as a paying customer, yes. Calculating non-paying downloads. The expression sum, case when paying_customer equals no, then downloads else 0 end, calculates the total downloads for non-paying customers. Similar to the previous case, it checks if the paying_customer column is no. If so, it includes the value in the downloads column for summation. Otherwise, it adds 0. This sum represents the total downloads for rows where the customer is categorized as a non-paying customer, no. By using these conditional sums, the query efficiently categorizes and sums the downloads based on the paying status of the customers, providing distinct totals for paying and non-paying customers in the final output. In this section of the SQL query, a subquery or derived table, named temp is created by joining multiple tables, ms_user_dimension, ms_s_dimension, and ms_download_facts, to extract specific columns for further analysis. Here's how this part works. Joining tables. The join operations connect the tables based on specified conditions. In this case, ms_user_dimension is joined with ms_cc_dimension using the common column acc_id. The result of the first join is then further joined with ms_download_facts based on the common column user_id. Selecting columns. From the join tables, the subquery selects three columns: date, paying_customer, and downloads. Date likely represents the date of the download activity. Paying_customer indicates whether the customer is a paying or non-paying user. Download specifies the number of downloads made by the user on a specific date. Creating a subquery. The results of these joins and column selections are encapsulated within the subquery temp. This temporary table is used to perform further operations like grouping and aggregation in the main query. By organizing the data in this structured manner within the subquery, The subsequent parts of the query can efficiently process and analyze the relevant information needed to calculate the total downloads for paying and non-paying customers by date. In this part of the SQL query, a join operation is performed between the tables ms_user_dimension, aliased as u, and ms_download_facts, aliased as d, based on a common column user_id. Here's how this join operation works. Joining tables. The join keyword is used to combine rows from the tables ms_user_dimension and ms_download_facts based on the condition specified after the on keyword. The condition u.user_id equals d.user_id specifies that the rows from these two tables should be combined where the user_id values match. Alias usage. The tables ms_user_dimension and ms_download_facts are given aliases u and d respectively. These aliases are used as shorthand references to the table names in the query to make it more readable and concise. Subquery formation. This join operation is part of a subquery, enclosed within parentheses, where data from the selected columns in the join tables is being extracted for further processing. The joined result set is stored temporarily as temp, which can then be used in subsequent parts of the query. By performing this join between the ms_user_dimension and ms_download_facts tables based on the user_id column, the query establishes a connection between user information and download facts, enabling the retrieval and analysis of relevant data for the specified analysis criteria. AI Avatar. In this segment of the SQL query, the data is further processed after grouping by the date column. Here's an explanation of each part. Grouping by date. The group by date statement groups the results based on the date column. This groups the data so that calculations can be performed for each unique date in the dataset. Filtering with having clause. The having non_paying_downloads, paying_downloads clause filters the grouped results to include only those records where the total downloads for non-paying customers exceed the total downloads for paying customers for a specific date. It acts as a conditional filter applied after grouping to further refine the data based on the specified condition. Ordering the results. The order by date ASC statement sorts the final output in ascending order based on the date column. This ensures that the results are presented in chronological order from the earliest date to the latest. By utilizing the group by, having, and order by clauses in this manner, the query effectively groups the data by date, filters out records where non-paying downloads exceed paying downloads, and presents the final output in assorted order for clear analysis and interpretation. Filtering records with having clause. The having clause filters the grouped results to include only those records where non-paying downloads exceed paying downloads. This ensures we only see dates where non-paying customers downloaded more than paying customers. Final output and sorting. The final output includes the date, total downloads for paying users, and total downloads for non-paying users. The results are sorted in ascending order based on the date column to show the data chronologically. In summary, this SQL query efficiently processes and analyzes the download data to identify dates where non-paying customers had more downloads than paying customers. The step-by-step breakdown helps us understand how the query extracts and compares the necessary information from the database tables. Thanks for tuning in today for our SQL coding session. We've tackled some interesting challenges together, and I hope you found them engaging and informative. Remember to hit the subscribe button and the notification bell so you don't miss out on our next exciting coding challenge. See you all tomorrow for another intriguing problem to solve. Until then, happy coding and keep exploring new horizons in the world of tech. See you tomorrow.